All right, guys, let's talk perpendicular bisectors. So you're going to use a compass and straight edge, be able to construct a perpendicular bisector to each of the segments provided. And then the bottom, we have kind of a weird question, but we'll get there when we get there. So perpendicular bisector, that means we're going to cross each of these individual segments straight down the middle at a right angle, but also cutting the segment in half at the same time. This one is actually way easier than I think the one we just did, because the one we just did required like 2 or 3 different distances to copy everything. This only requires 1. Because we have to cut down the middle, the circles and arcs we're going to use should all be the same distance apart. We shouldn't have to change the distance once we find it. And so let's recall that the steps we used are first to set a distance from either one of your endpoints. You can use the whole distance if you like, but I know you have to be kind of obviously more than half. That way we can actually find some intersection points. And so it's okay to use the entire distance, okay, but a little more than half is actually pretty good too. And we're simply going to now make an arc at the top and an arc at the bottom. Okay, we don't need to go all the way around. Of course you can if you'd like. We just know the intersection point's not going to be on the outside of the segment. So without changing the distance, we'll simply switch. It looks like we have a rogue line there, but we're going to go ahead and make our arcs again. So just using the principles as established before, we will just be looking for intersection points. Okay, and so in this particular case, we have an intersection point here, which I'm going to call A, and we have a one down here, which I'm going to call B. Okay. Now we do have to draw the perpendicular bisector, and it's just an issue of connecting or extending through these lines. And so again, you can just draw it from point to point, okay, or you can draw a segment, or you can extend it. It's all the same to us. Okay. Now as far as marking it, a couple of things should be here. We know it's a perpendicular bisector, so let's mark it as perpendicular. Bisect needs to cut in half, and so I know those have to be cut in half. And so we should probably call this middle point something. I'm just going to call it C. And so as a final statement, we can say 2 things. IC is congruent to CS. But we can also say that AB, I'll just call the line, is going to be perpendicular to IS. Right? And so perpendicular bisector, that's pretty much what's going on. Let's do one more, then we'll drop down to the bottom and take care of that. Let's go green. Right? So the steps here actually say, I'm gonna reverse them. I'm gonna go from right to left this time. And why not? I'll use the entire length if I can rotate. Okay, so I'll use the entire length as well. So I'm going to go from U all the way out to T. Not necessary, but certainly something you can do, and it'll work out just fine. And so I'll make a big arc here, which, and then from T, also make that arc. We're looking for intersection points, just like before. These are, of course, going to be farther out because we have a bigger radius. Okay, let's mark some points up. Okay, so let's call that A, let's call that B, and when we find our intersection point, right, and we find an intersection point, we'll call that C again. Okay, so we know we have a bisector that's also perpendicular. So we can say definitively that TC as a segment is congruent to CU as a segment, but also TU as a segment is perpendicular to AB, and why not? We'll just call this one a segment too. All right, and so number 3 is going to look very much like that as well, but for the purpose of the time, let's drop down to this example, or this particular problem. You're still being asked to make a perpendicular bisector, but as you can note, we actually want to make 2 perpendicular bisectors and see where they intersect. So this is just what we call an applied exercise. It's really no different than the top, other than you have to do this like multiple times. But that's really not that big of a deal if you think about it. As long as you know how to make 1, you can certainly make 2. All right, so we'll set the distance. Okay. For this one, I'll just use the entire segment length. I think that's fine. That's a very easy distance to take. It's a safe one. So let's see, arc top and bottom. Switch it up. Move the pin to the other side. Arc top and bottom. Right. Now this one's not really requiring us to make any kind of final statement, so I'm not going to bother like marking the intersection points like the last one. I'm just going to take the points, intersect them, and then draw the line out a little bit. I am looking for these lines crossed, therefore I want to make sure they're long. They're nice and long though. Okay, so we have perpendicular bisector here. All right, number 2. Let's choose pink. All right, I'm going to shorten this length. I did the entire length last time. I'm going to go about right there, I think. So arc 1, switch. Arc 2. Let's construct the actual bisecting part. Okay, so I'll intersect the 2 lines, extend it until it hits a blue line. Okay, and so we have to select the point where they intersect, which is right here. Of course, we can give it a name. For the purposes, we have to find where they intersect. Right? And of course, this one's also perpendicular and a bisector. Cool. Let's do number 2. Same motion, same thing. Weird off blue. All right. So we first need to find a length to make some arcs. Now we definitely don't want to go off the segment, but as long as we're more than half, we're good. Flip it, go to the other side. All right, boom, boom. Connect, extend. Okay, my guess is going to actually cross somewhere above it. That's my guess. The way these are angled. Okay, we have perpendicular bisector. All right, what color should we finish with? Let's go green. All right, so definitely more than half, so this arc length is good. Switch her up. Switch her up. There we go. Go from this side. Cross it. All right, so grabbing the line. We'll go from here and extend it. Ooh, looks like we barely caught the point, but we did catch one. That's the point where they cross. All right, guys, that's what we got to say for perpendicular bisectors. And so it's really using the same circle for both ends of the segment, but we're looking for intersection points. If you recall, a lot of the work is going to fall under these parameters where we're just kind of finding multiple points, points of intersection from multiple circles of different sizes. All right, I'll see you guys in the next part where we're going to tackle parallel and perpendicular lines.